In class on Sunday, I set up several Socratic quizzes, and I should say that I think having quizzes spooked some people. I wasn't really intending to use them as quizzes to assess and grade you. I just wanted to use the tool for teaching so that there could be some feedback on specific questions I set for you. Now, the first quiz was a follow-up to our study of scientific notation and how to use it properly. And the hardest question came at the end. I was trying to use businessman Michael Bloomberg to set a problem that required scientific notation. Bloomberg has so much money, it seems to require scientific notation to keep things straight, and he spends a lot of money, so that comparing what he has to what he spends seems to be a good example of using this. With scientific notation, it's harder to make a mistake that makes your answer some power of 10 times off from the real answer. With very large numbers, it's easy to get an answer that's 1,000 or 100,000 times off from the truth. When you're using very large numbers, the problem of making a simple arithmetic mistake, right, adding 5 and 11 and coming up with 14 or some such, that danger is less important than adding an extra zero or leaving a couple zeros off. And of course, that kind of problem makes your final answer much less truthful than mistaking 14 for 16 would have done. So let's turn to the problem. The original occasion for the problem is that the news is somewhat astonishing. Michael Bloomberg seems to be burning through huge piles of money, the kind of expenditure that could make any other people obscenely rich. But this makes one curious, think, well, it's a huge amount of money for us, but how much does it mean to Michael Bloomberg? We know that it is huge compared to the riches we've got, but when you compare it to the money Michael Bloomberg has, and you compare how much he's spending to how much he has, what does it mean? Now, there are a number of ways to approach this problem and a number of ways to express the concept. And one of the things to be careful about is to look precisely at what I asked and answer that. It would be possible to get the right numbers about Bloomberg and to use them in an intelligent way to produce some conclusion, but you should try to match the one that I actually asked for in the problem. You could get to the concept by asking, well, how many times could Michael Bloomberg pay that amount of money before he was broke? Now, that would inform you, but it's not what I asked, so you want to be careful about that. You could also ask, well, when he's spent all the money, how much does he have left? And that would do the same thing, give you a rough idea of the matter, but it wouldn't fulfill what I asked. What I asked about was the fraction that he spent. So then you could think, well, does that mean comparing what he spent to what he had at the start, or comparing what he spent to what he had left after he was done? And I'm looking for the fraction of the whole. So you want to make sure that you understand what we're doing, what general idea we're going for, but you want to be careful about the way to express that idea. The numbers are easier to get, but you have to relate them with the right operation. So here's the start of the problem, and at first I'm just asking for raw numbers. What expression do you give to the amount of Bloomberg's wealth? I think everybody got this right, and it would be useful for you to get familiar with the scientific notation for millions and billions and trillions as we deal with large budgets or large populations and you get into questions that I hope you will face in your career, it's handy to have those markers, those benchmarks, fresh in your mind. And here's the other raw number. How much has he spent in scientific notation? And here we get to the final problem and the final answers. Everybody comes equipped to this last question with the right numbers, but you'll see that only a little more than half of the people could answer the question, and less than half of them got the right answer. So we need a little remedial work on this question. Now here you can see that the first two students gave answers that are essentially the same, but are they the right answer? Well, we can start to evaluate that. What is the problem asking for? What are we looking for? It wants to know what part he spent in relation to everything he has. What fraction is the expenditure compared to the whole pile of money that he's got? So you could ask yourself, without doing any math yet, what sort of number are you expecting? Are you expecting a large number, a small one, or a zero, or a negative number? Maybe a more precise question would help. Do you expect more than one? If you're asking, what part of his whole fortune did he spend? Or are you expecting something less than one? Suppose we're not looking for a negative. I just threw that in to see who's thinking. So we weren't looking for anything less than zero, but are we looking at a number more than one or between 1 and 0? And if it's more than 1, is it close to 1, or is it a number in the thousands or millions and billions to be in touch with the raw numbers we're working with, to be similar to them? If it's less than 1, is it less than 1 but close to 1 and far from 0? Or is it less than 1 and near to 0 and far from 1? It generally helps you to solve problems to have a realistic idea of what the answer should be. Now, what these first two students did was to make a fraction with the expenses on top as what we call the numerator, and the whole fortune, the whole of Bloomberg's money, on the bottom as the denominator. And we're wondering, is that the right way to solve the problem? Now, you can ask yourself, what kind of number would that fraction produce? Is it something close to 0, something close to 1 but smaller, something more than 1? And does that match your expectations of what the answer should be? That's one way to make progress on this problem. It might help to compare this problem to a simpler one with smaller numbers. Suppose at the end of this semester 5 students get A's. There are 25 students in the class. How would you figure out what fraction of the whole class had gotten A's? How would you set up the numbers so you could figure that out? Would you do it this way, to put the smaller number, the number who got A's, on the top of a fraction where the numerator goes? And would you put the whole class on the bottom where the denominator goes? If you can answer yes to that question, then maybe this first way is the right way. But now here's a third answer, and maybe this is the correct answer. This student has done the same thing, but the fraction is inverted. It's upside down. The amount of the whole fortune is on top in the numerator, and the amount of the expenditure is on the bottom for the denominator. And then you could ask yourself, is that the right way to produce the fraction we're looking for? So you can look at the way the equation is set up, but also the answer it produces. It comes in scientific notation, 1 times 10 to the second power, which would be a 100. Is that the sort of thing you were looking for? And here again is a fourth answer. And now note that the numbers are the same, and we're back to the first order, but the operation is subtraction rather than division. And of course, that makes a certain amount of sense. It points to the concept we're looking for. What happens when you take away the amount of money Michael Bloomberg has spent from the amount of money he had? So, again, it points to the concept. And is that the right way to solve the problem? Does that follow my instructions? I want you to tell me the right fraction, the portion of the whole he has spent. So I'm going to leave this here. It's up to you to try to get a firm understanding of how to solve this problem.